All right, hey everybody. I want to get us into our second lesson. Now, this is where we're going to get into more of the trigonometry that you may be familiar with from your geometry classes and dealing with triangles. All right, we're going to look at our trig ratios. We'll get back to that in just a second. But before we get into that, there's another skill that we need to have, just like in the last lesson where we talked about simplifying radicals. In this kind of a preview of a skill, we need to talk about rationalizing denominators. Okay, remember in a fraction you have your numerator up top and your denominator on the bottom. We don't like denominators that are nasty, that are not rational. Okay, rational means we can make a fraction out of them. We don't like those. So let me give you a preview of what I'm talking about here. That radical square root of 3, if I do square root of 3 in my calculator, square root of 3 is this number that doesn't repeat and it doesn't end. It's called an irrational number. Okay, 3 is not a perfect square, so square root of 3 is an irrational number. We don't like irrational numbers in our denominators of fractions. They're just not nice. Okay, and this is a skill that's going to help you out on the TSI. It's going to help you out on your SAT and ACT, because all those answers that you're going to get in those standardized tests are going to be rationalized, meaning they're not going to have square roots in the denominator. So here's how we're going to handle it if we have a square root in the denominator. Okay, if your fraction that you have ends up with having a square root in the denominator, we are going to rationalize it. And the way we're going to rationalize it, we're going to get this 3 out from this radical. Okay, if you remember back to the simplifying radicals example I gave you, that anytime there was a pair of the same number under a square root symbol, we were able to write that number outside the radical. So for us, if we want to rationalize this, we want to give this guy a buddy. Okay, so what we're going to do, and again, you may want to have your notes out. So pause this if you need to, get out a piece of paper and start taking notes for yourself to look back at. Okay, the way we're going to give this guy a buddy is we're going to multiply it by another square root of 3. Okay, now if you remember your rules about fractions, whatever you do to the bottom, you have to do to the top. Okay, so if we multiply, when we multiply fractions, we multiply straight across, this top part becomes 5 square root of 3. In the bottom, since both of these are inside numbers, they're under the radical, we can multiply those together. This becomes square root of 9. Okay, well, what's the square root of 9? The square root of 9 is just 3. Okay, when we've written this, we have rationalized the denominator. We've taken that denominator from being under radical that we didn't like to having the denominator be a number that's not under radical. Okay, and again, the process was, since we didn't want this under radical, we gave it a buddy. All right, we multiplied it straight across in the numerator, straight across in the denominator. Okay, now let me take before I get to the next example, how would I write this in Canvas? How would I type this in if I was going to type this in? If I was going to type this in Canvas, I need to address two things. First, I need to address that there's a square root right here, and I need to address that there is a fraction bar. Okay, so if I was going to type this in as an answer in a Canvas assignment that you'll do a little bit later, probably tomorrow in class, I would write in Canvas in the line. I would type the number 5. And then I would do square root, SQRT, 3. And then I would use a slash for the divide, and then a 3. Okay, that's how I would type that in as an answer in Canvas. Okay? All right, let's go to the next example. Again, we look at square root of 10, and square root of 10 is not a perfect square. I'll just show you, again, square root of 10. Okay, it's an irrational number. We don't like irrational numbers in our fractions. So, again, since I don't like that square root of 10 in the denominator, I'm going to give it a buddy. Okay, and whatever I do to the bottom, I do to the top. Okay, so, again, I'm going to take a shortcut here. We know up here it's square root of 3 times square root of 3 is square root of 9. Square root of 10 times square root of 10 would be square root of 100, but the square root of 100 is just 10. Again, because it's going to have a buddy, it's going to be able to come out from the radical. Okay, on the top, this does not become square root of 20. These don't mix. Inside numbers and outside numbers don't mix. You can't multiply those two things together to make one number. You have to call it 2 square root of 10. Okay? I apologize for my poor writing here. Now, at this point, you have rationalized the denominator, but we always want to reduce our fractions, all right? Since 2 is an outside number and 10 is an outside number there in the bottom, I'm going to reduce that fraction. 2 goes into 2 one time, and 2 goes into 10 5 times. So really, this becomes square root of 10 over 5. I just reduced that, okay? All right, so now that's our rationalizing denominators. We want to always rationalize our denominators. We want to always simplify our radicals, and we always want to reduce fractions. Okay? Always reduce fractions. Always simplify radicals. And always rationalize denominators. Okay? Okay, now let's get into our trigonometry. Okay, before we get into our trigonometry, there are some things we need to define. All right? Since we're going to be dealing with right triangles, again, we have our hypotenuse. Remember, the hypotenuse is always the side across from the right triangle, the right angle. Okay? I'll show you a picture here in just a second, just kind of to highlight all this information and give you a visual of it. All right, you're going to start seeing this little symbol here. It's not a O, it's not a 0. This is the Greek letter theta. Okay? Take a second and say that out loud. Theta. Get used to saying it. Theta. All right? The other two things we need to be able to label on our triangle are the opposite side and the adjacent side. Okay? Opposite means across from. So when we label the side of a triangle that we're going to call the opposite, this is the side of the triangle that is across from the reference angle, the side that is across from theta. The adjacent side, the word adjacent means next to. So the adjacent side of the triangle will be the side of the triangle that is next to the reference angle, theta. And it's not going to be the hypotenuse. Okay? You always have to find the hypotenuse first, then figure out where theta is, then you're going to label the opposite and adjacent sides. Okay? Let me show you a picture. Okay? Here's what I'm talking about. Ignore this for now. I'm going to come talk about this in a second. Okay? If I have this right triangle, the hypotenuse is always across from the right angle. That's the hypotenuse, always. Since this is where theta is, the opposite side is over here. Since this is where theta is, the adjacent side is right here. All right? I could take this triangle. Let's take this right here. Let's group it all together. If I take this triangle and I rotate it around, notice everything else is relying on where theta is. Okay, the hypotenuse always depends on where the right angle is. It's always across from the right angle, but the opposite and adjacent are always in relation to where theta is. Okay, if I were to put theta up at the top, okay, if I were to put theta up here, then this other side would become opposite and this side would become adjacent. Okay. Just side note here, we use Greek letter theta most often, but we could use an alpha. We can use a beta. We use Greek letters a lot of times in pre-cal and math classes. We use our Greek letters often for just angles. Okay, we want to distinguish them from an x or from just a regular value. So we'll use Greek letters a lot of the time. So don't freak out if you see some of these. You got theta, alpha, and beta. We'll use those a lot. Okay. All right, now let's talk about our trig ratios. Some of you may remember from your geometry class this SOHCAHTOA phrase. This is our magic word. When you get your paper out to do work for your assignments, and I encourage you, not only should you be taking notes on these on your own paper, you should be doing the work for the different problems that are in the quiz questions in Canvas. You should be doing that work on a separate sheet of paper too. My advice would be write this at the top of your paper. Okay, so let's talk about what this all means. Okay, this first trig ratio, is sine. Okay, take a second and say that. Say sine. Okay, not sin. Don't say sin. We're going to write S-I-N, but we're going to say, when we talk to each other, we're going to say that that is sine. Okay, again, try saying it. Sine of theta in this triangle is always defined by O and H. O means the opposite side. H means a hypotenuse. So sine is opposite over hypotenuse. That's what this first three letters stand for in our SOHCAHTOA. Sine is opposite over hypotenuse. Okay. The next trig ratio is cosine. Take a second and say that. Say cosine. I know it sounds weird because you're talking to a video, but trust me, the more you say it to yourself, the easier this stuff's going to get. Okay. Again, this is cosine. Don't say cos. Say cosine. We're going to write COS. We're going to abbreviate it, but we're going to say, when we talk to each other, when we talk to other people, we're going to sound like we know what we're talking about. We're going to say that that's cosine. Okay. Cosine is this next three phrase, the part of our SOHCAHTOA phrase, CAH, and that stands for cosine is adjacent over hypotenuse. We're going to make fractions. We're going to make ratios out of these. Okay, cosine is the ratio of the adjacent side to the hypotenuse. All right, the last part of our magic word, our trig magic word, is TOA, and the T stands for tangent. Again, say tangent. Don't say tan. When we talk to each other, we're going to say tangent. Okay, tangent of theta, and again, here's theta. Tangent of the angle that we're talking about is the ratio, the fraction, of the opposite side to the adjacent. There's the TOA, opposite over adjacent. Okay? So, again, when we get our papers, we're doing our work, we're going to write this down. This is our trig magic word. When it comes to right triangles, this works all the time. SOHCAHTOA. S stands for sine. O stands for opposite. H stands for hypotenuse. C stands for cosine. A stands for adjacent. H stands for hypotenuse. T stands for tangent. O stands for opposite. A stands for adjacent. Now, if we're going to use this, the most important thing we can do when we see a triangle is to label it. Always label the hypotenuse across from the right angle. Figure out where theta is. The opposite side is across from it. Label that. And the adjacent side is next to it. Now, this can't be the adjacent because we've already labeled the hypotenuse. It's the other side that's next to it. That's the adjacent. Okay? And abbreviations might be helpful. All right? So let's do some examples. All we're going to do is set up our trig ratios. We're not going to do any solving. We may have to do some rationalizing. We may have to do some simplifying of radicals, but we're not going to do any solving right now. We're just going to be writing some fractions as our answers. All right? So let's look at our first example here. Okay. Now, I've already put the labels on here, but one of the jobs you're going to have when you get your to do your assignment is once you draw this triangle out, because that's all I'm going to give you. Draw this on your paper. Draw that triangle. Okay. Put everything where it's supposed to go. Then put a label on it. Okay. And again, the things we want to label are the opposite, the adjacent, the hypotenuse. Okay. I would always start with the hypotenuse. Okay, here's the right angle. Across from it is where the hypotenuse is. Always. Doesn't matter how I spin this triangle around. Right angle, across from it, hypotenuse. And I'm okay if you just want to abbreviate it. If you just want to say that's the hype, that's fine. All right. Next, we want to label the other two sides. The adjacent is the one next to it, but it can't be the hypotenuse, and the opposite is the one that's across from it. There's your opposite. There's your adjacent. Okay. And again, if you want to abbreviate them, that's the ADJ, and that's the OPP. That's fine. Okay. Now let's go back over here. We want our trig ratios, so let's write down our magic word. Do you remember it? SOHCAHTOA. SOHCAHTOA. Okay. And again, this reminds us what our trig ratios are. Sine is the ratio of opposite over hypotenuse. Okay. So let's go find the opposite side. The opposite side was 15. And the adjacent side is 20. I don't need that for sine. I need the hypotenuse. So the hypotenuse is 25. Okay, that's the opposite. That's the hypotenuse. That's what that's the SOH part of SOHCAHTOA means. Okay, now this is our ratio, but remember, we always want to reduce our fractions. Okay, reduce that fraction. 5 goes into both of these. 5 goes into 15 3 times. 5 goes into 25 5 times. So that is our sine ratio for this particular triangle. Okay. Next, let's do cosine. Again, we want to rely on our magic word, the CAH. C stands for cosine. Do you remember what the A stands for? A stands for adjacent. So we set up our fraction. Adjacent is 20. Do you remember what the H stands for? H stands for hypotenuse. It's 25. And again, we want to reduce this. Can you think of something that goes into both of those? Yeah, 5. 5 goes into 20 4 times, and it goes into 25 5 times. So this is our cosine ratio for this triangle. All right. Now this last one. Remember, we're not going to say tan. We're going to say tangent. So tangent for this, again, we go to our magic word. Tangent is opposite over adjacent. Opposite was 15. Adjacent was 20. Okay, and again, reduce it. Again, 5 goes into both of those. 3 over 4. Okay, and that's what you're going to write in those different boxes on your assignment. You're going to write the trig ratios for each of the defined trig values here that we have. Sine of theta, cosine of theta, tangent of theta. These are all contingent on where theta is. All right. Okay, let's do the next example here. Let's not do that one. Let's go do this one. I'm going to drag these off real quick. All right. So here's our triangle now. Okay. Excuse me. All right. So now, again, we want to start off by drawing this down in our paper. Put that triangle down there. Put everything where it belongs. Then label it. Okay. Where does the hypotenuse go? Remember, that's the thing you should find first. Find the right triangle. Find the right angle. Across from it is the hypotenuse. Label it. Get in the habit of labeling it. Okay. Then I'm going to find theta. Across from theta is the opposite. Okay. Notice the opposite's not on the side anymore. It's not on this side because theta is in a different place. Our important reference angle is someplace else. So now the opposite is always across from theta. The adjacent is always next to theta, but it can't be the hypotenuse. So this must be where the adjacent is. Okay. Did you notice something about this triangle? We don't have all three sides. If we want to use our trig magic word, we need all three sides. If we're going to write our ratios, we need all three sides, right? I don't have a hypotenuse number. I can't leave this blank when I'm writing my ratios. So I have to go find the hypotenuse. How are we going to do that? Well, if you remember what we talked about yesterday, if you have a right triangle and you're missing a side, use the Pythagorean theorem. A squared plus b squared equals c squared. Remember, we called that hypotenuse was always the c, and we're missing the hypotenuse, so we ought to be able to fill everything in. 3 squared plus 2 squared equals c squared, or if you want to call it an x, doesn't matter. Okay, let's simplify it. So we've got 3 squared is 9, 2 squared is 4, equals c squared. 9 plus 4 is 13, equals c squared. Are we done? No, we're not done. We need c, not c squared, so we are going to square root to undo a square. Square roots undo squares. Whatever you do to the right side of the equal sign, you do to the left. Okay? Now, is 13 a perfect square? No, it's not. And there's no way to break it up other than 13 times 1, so that's what a hypotenuse value is, square root of 13. Okay, so we needed to figure that out before we can come over here and do SOHCAHTOA. All right. All right, remember, sine, opposite over hypotenuse. So the opposite side over the hypotenuse. Okay. The opposite side, here's theta. We labeled the opposite side 2. and the hypotenuse was square root of 13. Okay? Remember, like we talked about at the beginning of the lesson, we don't like radicals in the denominator. So we got to rationalize it. Rationalizing means give it a buddy. Give it a buddy. Another square root of 13 in both numerator and denominator, because whatever you do to the bottom, you do to the top. So the top becomes 2 square root of 13. And since the bottom has a pair of 13s under radicals, we can just say that that's 13. Remember, when you simplify radicals, if it's got partners, we can write that number 1 time outside. Okay? Again, remember, when you write this in Canvas, you would write 2 SQRT 13/13. Okay? For cosine. Remember, we're going to use our trig ratio CAH. That's from our magic word. Cosine is adjacent over hypotenuse. So again, look at your triangle over here. The adjacent side over the hypotenuse. ADJ is 3. The hypotenuse, again, square root of 13. And again, we want to rationalize. We don't like radicals of the denominator, so we give it a buddy. Give it a buddy. Whatever you do to the bottom, do to the top. 3 square root 13 over 13. Okay? Finally, we want to do tangent. Remember, we're not going to say tan. We're going to say tangent. Give it the right name. Okay? Tangent, again, magic word, opposite over adjacent. Again, go to your labels. Opposite is 2. Adjacent is 3. No rationalization needed. There's your 3 trig ratios. All right, now you have everything you need for the assignment. Come to class tomorrow with some questions. If you're lost, let me know. Join us in the Teams meeting. We'll see you then.